Question 4D. This is a really common format for OCR questions. If you've seen any of the old coursework F323 or F326, they all have this similar format, and tables for OCR are always drawn in the same way. Before I approach any question, what I would always do is I would calculate the mass readings and temperature readings, because generally these are needed at some point during the question. Think, what are they? What do they actually represent? And also think, do you need all of them? So sometimes you do, but sometimes also you don't. And they're put in there as a little bit of a confusion. So the first mass reading represents the sulfuric acid mass. The second reading represents the mass of the solution, all of the solution that you have present, which is combined from water with your sulfuric acid. And then the last one represents your temperature change, so your difference in temperature. The question then asks us, use the student's results to calculate the enthalpy change of solution of sulfuric acid in kilojoules per mole, assuming that specific heat capacity is the same as for water. Again, you see how it says use an appropriate number of significant figures, so we are now stating that that will always be 3. To answer this question, we're going to need the number of moles of sulfuric acid if we're calculating the enthalpy change of solution of sulfuric acid. This is equal to the mass divided by the molar mass. Now take care here that you're using the correct mass. It is too easy to get confused between the mass here and the mass here. So make sure that you're using the right numbers at the right time. If we divide through, we end up with a value of 0.115 moles. We're then having a question that is based around enthalpy. For this question, we're therefore going to need Q equals mc delta T, something that you're going to need to remember. So Q, the energy that we released, is equal to the mass times by the specific heat capacity times by the temperature change. The mass, this is the mass of the solution. Any enthalpy changes, you are looking at the mass of the solution. The mass of the solution is the mass of the sulfuric acid added to the mass of the water. In this case, it's 113.42. Again, care that you're using the right numbers. C is 4.18, and your delta T, your change in temperature, you calculated on the final table at the bottom as 10.5. This gives us an answer of 4,978 joules. This number of joules is the amount of joules that are required for every 0.115 moles. It asks us at the top to calculate the enthalpy change of solution of sulfuric acid in kilojoules per mole. Now, that means that it wants it for 1 mole. So whenever you've got enthalpy changes, so you need to learn all of the standard enthalpy changes, you will always have somewhere a relationship with 1 mole. So we need to convert those 4,978 for this many moles into per mole. So we divide the amount of joules by the number of moles we have, which gives us 43286 joules per mole. Now this is the amount of energy that is released, therefore it's an exothermic reaction, and we're going to need our negative sign to express that. The other thing that we have to be careful of is that right down here, and as it states in the question, it wants it in kilojoules per mole. So I've been working through, I've got my joules, but now I have to make sure that I'm converting it into kilojoules in order to secure that fourth and final mark. So the negative sign and the conversion into kilojoules is necessary for us to get this answer. This answer wouldn't get us 4 marks because the question's asking us for an appropriate number of significant figures. So we have to take this value and we have to break it down further to 43.3 in order to have it to an appropriate number of significant figures. You would lose 1 mark if you didn't quote it to 3 sig fig. Next question, the student thermometer has a maximum error of plus and minus 0.5. Calculate the percentage uncertainty in the student's temperature change to 1 decimal place. So again, making sure that we are quoting to the number of sig figs or decimal places in the question. So here we take our value, our error, stated in the question. We divide through by the amount that we have measured. So our temperature change is 10.5 degrees. Thinking about if it's liquids or fluids, it's not the amount of fluid that is held in the vessel, so the measuring cylinder, it's the amount that you're actually measuring out. In this case, because it's a temperature change, we have to take 2 readings in order to get our temperature change. So the error that we have is going to be doubled. 2 lots of error divided by our actual reading of 10.5. So that's the reason that we're doubling it up, and that gives us a percentage uncertainty of 9.5%. The next question, the student carries out a second experiment using 150 centimetres cubed of distilled water instead of 100. The mass of the concentrated sulfuric acid is the same. predict and explain the effect of the larger volume of water on the following two things. So the temperature change. The amount of energy that is released during this experiment is exactly the same. But if we have got two situations, one where that energy is spread out over 150 and one where that energy is spread out over 100, we are going to have a difference in the temperature change. Because if we're spreading it out over a greater volume, the temperature change is going to be less. So the same amount of energy is released, but it is spread over a larger volume, so delta T will be less. That would get you 1 mark. We actually have to give a number, we have to give a value to get the second mark. So working through, if 100 centimetres cubed give us a temperature change of 10.5 degrees Celsius, 150 is going to be roughly 7 degrees, because here we're looking at roughly a third. So it's a third more, if you like, so an extra 50. So this one is going to be roughly a third less because it's spreading it out over that greater volume. That isn't explicit in the question, the fact that you need a value, but it would be good practice if you have numbers, if you have values, where it is possible, make sure that you have a quoted figure. To get the next set of marks, or the next 2 marks, the enthalpy change of solution is the energy per mole. If it's the energy per mole, then the actual delta H calculated is going to be the same. If you think about it, if Q equals mc delta T is going to be going down, but your mass of solution is actually going to be going up. So your C remains the same. You've got one value going down and one value going up, which means that Q effectively can remain the same even though both of those values are actually changing.